Hi, I'm Dr. Rod, registered architect and design practitioner in New South Wales, Australia. Today we are going to review wall details for external and internal walls. Please be with me.
Defining wall types are important for CC or CD drawings and affecting many details like waterproofing and all other things. Particularly sheets affected by that is wall setouts, wall type sheet, and fire compartment as well. To identify the wall types, we need to consider a couple of things impact on the wall compartments. And in this video, I'm going to share with you common wall compartments according to Australian standard. By considering all of these factors, you can decide about each wall compartment and make a decision about them. Acoustic, thermal, weather, fire are key factors that you need to consider to make a decision about the wall compartment. You can get consultation from acoustic experts especially about the insulation type, but the main things would be discontinuity in party walls. Thermal insulation, weather insulation, also you can get consultation from waterproofing guys. And if that's an external wall, maybe you can get some idea from your facade engineer. Actually, those details needs to be reviewed by those experts. Once coming to the fire rating level, then your BCA guy and fire engineer can help you about those factors. Finding the fire rating level is a bit complicated, and I'm trying to give you the sense in a simple way. What you need to do actually, if you check the building classification and each space classification can help you to find the fire rating level in BCA. For each part of the building, there are two different concepts. One of them is the entire building that can be, for example, building class 2, 3, or whatever. But once coming to a specific space, for example, when there is a storage or waste storage in the basement, that is class 7B in a building, which could be class 2, for example, residential, or class 3 as a hotel. For that particular classification, if you go to BCA, you can find out their required fire rating level. In the next slide, I will tell you exactly how does it work. As you can see in these tables, Class 3 identified to have a floor rating level of 90, 90, 90. Class 9 is 120, 120, 120. Floor and roof are not the same, and once coming to the wall, still you can see some differences. So based on those classifications for each space, there is a schedule telling you what should be the fire rating of that wall or roof or floor. That one can be reviewed by your fire engineer before providing the fire report, which called FABQ. And also your BCA guy will providing probably a report for you showing how he classified the building and how he identified each fire rating level for each wall and fire compartment. At the end of the day, you need to send all your wall types when you provide the fire compartment plan to him to review. As you can see in this example, we provided a sheet with a legend while fault resistance levels are showed in different colors, and those colors are applied to the walls in the plan. And that fire compartment plan is supposed to be reviewed by BCA consultant to make sure complying with the BCA codes. If there is any issue, for example, if you cannot achieve one of those requirements, then that one can be reviewed by your fire engineer as well before providing uh, FABQ and providing a performance solution for that one. All those things are important because when you are going to make a decision about the wall types and wall compartment, the overall fire rating should be matched with this plan. That's why you need to select the material that direct you to this level of fire resistance. That happening in acoustic matters and also all other factors impacting on walls as well. In this part of video, I'm going to review internal wall types, which is mainly including service wall, which is usually between a residential unit or corridor and a riser or shaft, or corridor wall, which means between residential unit or a hotel bedroom and a common corridor, party wall between two residential units or between two bedrooms in a hotel. We are going to consider all details now. As you can see in this example, service wall, it's usually all around the risers for hydraulic or mechanical or other things like this one. For this type of wall, it's important to know if that riser making noise or not. For example, if it would be a mechanical exhaust, maybe we need to add additional layer of acoustic insulation that you need to check with your acoustic consultant. But in typical situation, if that wall is between dry area and a riser, that would be including 30 millimeters plasterboards, 28 millimeters for fairing channel only. We need a fairing channel. Technically, we need a fairing channel because in case that you need to cross some cables for switches or something, then you have a space for that one. And then 75 millimeters Hebel wall. If that one is between a unit, for example, and the fire stair or leaf, then we need an additional layer, which would be air gap, 25 millimeters air gap to absorb the vibration coming from the lift or coming from the staircase. As you can see in this example, would be 13 millimeter plaster boards, 64 millimeters stud wall, and insulation. Mainly we need to have a thicker insulation because fire stair or a lift shaft can be a little bit cooler. And also we need a 25 millimeter gaps and then concrete wall, which is part of the lift or the stair. The other type of wall, it's corridor wall. In corridor wall, there are a couple of things to be considered. That corridor wall, usually because of the fire rating and acoustic things, we need to use the Hebel and 64 insulation. And some people would like to have an air gap for this continuity of heat, but it's not really necessary. It's up to you. That's a better practice, obviously, but it's not necessary. The other type of wall, which is very important, it's a party wall. Party wall is between two units or between two bedrooms in a hotel. In that one, it's really important to keep and maintain this continuity. That's why it's important to have at least 25 millimeters gaps. Some guys saying because Hebel may not be really straight or material that or other material that may use for human error, and considering all those things, maybe they add additional 10 millimeters to the air gap and make a 35 millimeters air gap. And then would be plasterboard, fairing channel. Again, fairing channeling is there because you may need to use it for some cabling and all those things related to electrical metals. Give you space to accommodate that. 75 millimeters Hebel wall and then 25 or 35 millimeters cavity. Then on the other side can be 92 or 62 millimeters stud wall, depending on the insulation that you need. And usually you need to get that advice from your consultants, and plus 13 millimeter plaster boards. Using Hebel is not really necessary. It was a project that we used two studs next to each other and using thicker gyprock or fire-rated gyprock. As I mentioned earlier, it's important to maintain the level of fire rating and achieving the level of acoustic and all other things. So it doesn't really necessary to be exactly this material. And for that one, for example, we use 13 millimeters gyprock and then 64 stud and insulation, the cavity, and then insulation 64, and on the other side, 30 millimeters gyprock. The situation became a little bit challenging if there is a column in between on a party wall. Then would be important how we can digest the concrete column in the party wall. If the party wall is thick enough, you can you can accommodate the column in between. In that case, you need to make the cavity a lot wider. But usually builders and the clients don't like that one because it's wasting their space. So what's happening? The system will go all around the column. As you can see in these details on the left side, the cavity stop once reaching to the column, but continues on the other side. At the left side, there is a plasterboard fairing channel again for the cables and insulation, and the 75 millimeter Hebel wall. On the other side, it's 13 millimeters plasterboard, 64 stud and insulation, and that system repeats the same once coming to the column. As a result, you will see a kick next to the column. Uh, it depends on the type of insulation that you are going to use. Maybe that 64 millimeter insulation and a stud wall next to the column can be changed with 28 millimeters 28 millimeters framing channel. But for removing the cavity, it's important to consider that if the column would be thinner than 250, usually that is not recommended. But if the column is thicker than 250 or 250 millimeters, maybe you can get rid of that 25 millimeters cavity. That needs to be checked with your BCA consultant, or acoustic consultant. External wall types. External wall types also are very key matters in deciding about wall types and providing wall details. Key factors for all those things obviously is the strength and water and weatherproofing. For external wall types, in addition to acoustic insulation, you need to get help from your facade engineer as well. Sometimes waterproofing consultant also can help you. In this video, we are going to review face break, break slip, hebel wall, curtain wall, and cladding wall, which would be including fiber cement or aluminum. Let's talk first about the hebel wall. Hebel wall is very common wall. Hebel wall, it would be including 75 millimeter hebel, 35 millimeter cavity. That cavity is important for weatherproofing because if there is any moisture or water, would be a stop in that cavity. And it's important to attention that mm, in these kind of walls, I mean, in all of external walls, we have two different skins, external skins and internal skins, right? And usually we need to have a cavity between these two, around 35 millimeters. In this case, after hebel and cavity, there is a sarking and 92 millimeters stud, which is including the insulation, and 13 millimeters plasterboard on the internal side. Face brick wall. Face brick wall is very similar to hebel wall, which is including 75 millimeters brick, again 35 millimeters cavity, sarking 92 millimeters stud wall, plus 13 millimeters plasterboard. And depends on how you would like to, for example, the brick wall would be sitting on a slab or would be overhanging and attached to the face of the slab. The detail can be different. You can see one of those examples here. And it's, as I mentioned before, it's important to maintain that cavity. Brick slip wall in somehow it's similar to brick face, but it's not that much thick. Brick slip would be less than 13 millimeters, and each brick needs to be hauled mechanically. And the system, well, the base wall can be anything, can be a stud wall, block wall, but usually after that there is a railing 35 millimeters, and on top of that there is a top hat 25 millimeters usually, depending the provider can be different, and the brick slip by itself is 25 or 13 millimeters thick. Railing and top hat together are acting like a cavity that we had in the previous walls. That's why external wall would be thinner. Cladding can be including fiber cement or all other aluminium types. Of course, fire rating and all those things are important, and you cannot use the material which are fireable. But apart from all those things, the detail would be including like all other typical walls, 13 millimeters plasterboard internally, 92 millimeters stud wall, and insulation inside that. And after that, again, there is a railing 35, like a brick slip, 35 millimeters, railing 15 or 25 millimeters for the top hats, and another 15 millimeters for the thickness of those fiber cements. One of the brand would be Acutone. Another high technique wall is curtain wall, which can be glass, brick, or any other type of material. That one also heavily needs a facade engineer get involved, and also acoustic and thermal and everyone else to provide you some advice to how to manage that one. This kind of wall is not sitting on a slab. I mean, it's somehow holded by a slab, but it's not like a traditional wall. It's overhanging somehow, and that one can be like a backpan glass or brick or transparent glass, but usually they have a railing and hangers behind and connecting to the slab. In somehow you can see some of those details. The right one is for the glass, the middle one is for the brick. I hope all those things can help you when you are going to make a decision about the wall types, and we are going to provide more details in future videos.